This code takes 5 seconds to run, while this code takes half a second to run. They're both the exact same thing, but can you spot the difference? A database index is what makes this code run 10 times faster. Imagine you store 100,000 restaurant menus in your database, where every menu has 5 categories and 5 items on average. If you wanted to get the menu for McDonald's, you would have to scan through 500,000 entries in the categories table and 2.5 million entries in the items table. This is what we call a linear O of n operation, and this is why this code takes 5 seconds to run. But if we add a database index, we can improve the performance from O of n to O of log n. Indexes use something called B-trees that point you directly to the data that you want. A B-tree in the categories table knows exactly where McDonald's is and points us to all the category nodes in the McDonald's menu. And a B-tree in the items table will point us directly to the McDonald's burger category, and it'll give us all the item nodes that belong in that category. So instead of scanning the entire database to find all the menu items and the categories in linear time, indexes point us directly to this information in logarithmic time. Adding an index to a table is actually pretty easy. Most RMs provide an index method to help you create it through code, or you can run a SQL query to your database that does the same exact thing. Performance issues like this is pretty hard to catch early on because everything runs pretty fast when you only had 10 restaurants onboarded. But as your database starts to scale, a few lines of code can make your queries 10 times faster. I created an index on the subscriptions table to remind you to subscribe to my newsletter, dailysystemdesign.com. We send a system design newsletter every day and it's totally free.